Yeah, appreciate everybody's time and joining our session here. Excited to have you guys talk a little bit about IR inspections and the thermography machine learning process that we're going through at POC with the PwC team. We got Bruno here with us, who's going to kind of help walk us through some of that really cool stuff. But we'll jump ahead to our intro slide. Again, my name is Alex Cambiano with Evergy. I oversee our substation and transmission Maximo implementation, and also the planning and scheduling for all of our substation inspection, maintenance, and construction work. For that, I'll pass it over to Jesse, does our reliability team.
Yeah, I'll try not to read straight off of that, but been with Evergy for 10 years now, did a couple years in operations and generation, about 5 years in generation reliability, testing all the electrical assets at all our power plants, and then that translated nicely to a role as manager in the transmission and substation asset management team.
Yep. And of course, the brains behind our machine learning operation, Bruno. Hey.
That's what I should have said.
I'll sit here. They will take you over. Let me get the demo ready. Thank you.
Awesome. All right, well, with that, we'll just kind of dive right in here. So a little bit about Evergy. We have about 930-ish substations, about 10,000 plus miles of transmission line, and over 50,000 miles of distribution line, focused mainly in the Missouri and Kansas areas, so eastern Kansas and western Missouri, northwestern Missouri, Kansas City area, Topeka, Kansas, Wichita, Kansas, those areas. Generation, transmission, distribution, substations, all of the power generation delivery world, that's all us. And again, we've got about 150 substation technicians that work with us, specifically kind of focused on what we're going to be talking about today, working in substations. So,
although we're talking mostly about transmission and substations, we didn't include there, it is about 16,000 megawatts of generation, so FYI.
Yep. Jesse keeps me honest.
I have to.
He does.
8 years of generation.
Too much time in generation.
Don't want to let him forget.
No such thing as too much time. All right. So moving right along here. So pass it off to you for some of the high-level IR stuff.
Mike's working. So I guess, I am going to read a little bit off of this, but how many of you in here are familiar with thermography, just the concept of it in general? Yeah, okay. Great. As it says here, thermal energy or imaging is a non-destructive, non-intrusive test technique used to detect and analyze thermal patterns and anomalies in objects or systems. It involves using an infrared camera to capture and measure infrared radiation visible to the naked eye, which can then be used to identify potential issues or faults. So basically, it's just looking for light wavelengths, and it's able to put it on a picture that you can use. And sometimes, this is what they call a rainbow palette right here. This is probably most commonly used. There's also one called iron. Don't like it. It essentially looks like iron. There's a black and white. Also, this right here, it's colorful, and it's kind of exciting when you see something that you're not supposed to see. So I like that one. Next, please. So the history, so it was used for maintenance purposes back to the 1960s, primarily in military and aerospace applications. As you can see there, 1960s finest PPE in a substation right there, a three-piece suit, no hard hat, nothing, so probably no boots. But over time, technology became more accessible and affordable, leading to its adoption in various industries, including utilities, manufacturing, power generation, building maintenance, healthcare. Today, infrared thermography is utilized by maintenance professionals worldwide to enhance equipment performance and reduce unplanned downtime. Thank you. So, applying to predictive maintenance, proactive approach to maintenance that aims to identify and address potential problems before they lead to equipment failure or downtime. By analyzing the thermal patterns of an object or system, technicians can detect abnormal conditions, underlying issues like electrical faults, mechanical wear, insulation problems, fluid leaks. This technique allows for early detection and timely intervention, leading to improved equipment reliability, energy efficiency, and cost savings. Thank you, Alex. So here, this is going to kind of illustrate a little bit about Evergy's approach to thermography, commonly known as IR. You'll hear me probably say IR a lot. So the personnel involved it really starts at building a PM. So the planning and scheduling team, it'll kick out a work order. The planning and scheduling team will essentially plan and schedule, as it implies. Substation maintenance folks will go out and they'll actually do the scan of a substation. Like Alex said, we have about 930 substations throughout 2 states, so it's no small feat to get all of those scanned. Lots of assets in there. At that point, comes back, supervisors will sign off, acknowledging that the work's done, and sometimes we'll do a preliminary assessment of anomalies if any are found. Oftentimes it's my team, asset management, reliability engineers, who are the ones evaluating these pictures though. So supervisor sometimes is the front line, and they'll get an alert that says anomaly detected. They'll take a look at it, and if they'll maybe get a second opinion or decide if something needs to be followed up on. So coverage, full substation scan, major assets. So they're walking through, substations can be as small as this room or 10 times the size of this room. It really varies pretty dramatically. It just depends on the high and low side voltages of the station. But switches, breakers, transformers, bus components, conductor basically, arresters, capacitors, batteries, reactors, lots of components to the transformer itself also. There's low tap changers, bushings, or arresters on the actual transformer. Procedure, so IR scans, like I said, are conducted annually by the craft. When an anomaly is detected, file is sent to Maximo for review, supervision, asset management. And what we use is FLIR. That's generally what we use. We've got a few different cameras. We use an E5, kind of looks like a little joystick with a TV on top of it, really, and those are pretty commonly used throughout any industry, honestly, because they're pretty affordable, a couple $1,000s, and you can get yourself the little FLIR suite to evaluate as well. We also use a T640 and a T1020. Nobody asked, but I'm gonna go ahead and tell you anyway. Those are the more expensive ones, so if you need a little better evaluation, you got a lot better zoom, pan tilt zoom, kind of, rather than just having, it's very, primitive, I guess, if you're using the base model, but it is better than nothing, I'll give them that. Next, please.
So I think this one's back to me. So basically what we're looking to do with our machine learning model is within Maximo Visual Inspections application under the MAS suite, is essentially train a model that can ingest these pictures that we take with an IR camera and take some of the guesswork away from the technician who is trained in infrared thermography today, take some of that guesswork away from them having to analyze, is this a priority 1 hotspot? I've got a really, really bad issue. I need to address that right now. That thing's about ready to light up on fire. Or is this a priority 4 hotspot somewhere in between where, yeah, this is an issue, but I don't need to address it right now. There's a lot of judgment that goes into that, and again, we pay these folks really, really well. We teach them, how to use the infrared equipment. So there's a lot of education that goes into that, but take some of that guesswork, take some of that variation away from them, and move it into a model that's going to get a little bit more consistent results for us and auto-populate. Here's this picture. This is what that returns. Here's that result. So. With that, kind of jump in. So there's a little bit more, just again, some of the benefits, improved efficiency, accuracy that comes along with that. Again, take some of the guesswork away from those pictures being taken and just immediately feed those in as we feed in those pictures. As you're aware, most of you that have any experience or even heard some about machine learning models, the more you show them, the more you provide them, the more they learn from each other, and you can help validate and provide more feedback and more results just to make your model and everybody else's, for that matter, that much better as they learn. So with that, Bruno, if you're ready, I will pass it off to you for the rest of the slides.
I'll add before he picks up.
Jesse.
Yeah, that's all right. What we're excited about with this, and we're still in a development phase with PwC on this right now, for the record, but what's exciting about this is it sort of takes, we talked about, there's a guy or a gal going out there and doing these scans, and so it takes some of the subjectivity out of it, some of the human performance issues that you might run into, so somebody's supposed to go out there. The way we currently do it, the craft person goes out there, they see something, and there's an expected range, or a lot of times for us, we're fortunate enough that You know, a lot of times we're dealing with three-phase power, so we're looking for one of them doesn't look right out of the three. It's pretty easy to say, oh, that's the hot one, you know, but if maybe it's like, say, it's not quite to the range, or maybe Joe, you know, feels comfortable, it's getting hot, but, you know, it's going to take a little bit extra work to take that back to the office, you know, and import it, you know, and do all those extra steps, you know. So not to imply that's what happens on a regular basis, but, you know, you never know. So it does create extra work for whoever's out there doing it. So what we currently do is if the person goes out there and finds something, they capture a photo and bring it back. If they don't find anything, they're not bringing anything back. So we're talking about changing that process. So they're going out there. We're paying them to roll a truck. They're going out to their substation. They're, you know, walking through it. They're already pointing at all the points that we want to capture. So what we're talking about doing is pull the trigger every time. So they're taking a photo of all these things and bringing them back and importing them to the software, which Bruno will get into a little bit of how that's going to work. But that, you know, with us sending somebody out there and not capturing something, it almost feels a little bit like a waste of resources, money even, you know, if we're not actually capturing something. And it also, one thing that we get about thermography, it generally goes from normal to get somebody out there immediately and fix this, because it's very alarming, you know. So we don't really have a mechanism to trend this right now. So it's either okay or way too hot, you know. And so this is going to help us with some of that, help us evaluate whether there's a slow increase in something, and I'm pretty excited about it. So Bruno, go ahead whenever you're ready.
So, I'm sorry, we had a tech glitch. But now everything looks fine. My name is Bruno. I work for PwC. We're supporting Avergy in this effort, in this journey, as they say. You know, upgrading their Maximo system and then going beyond with innovation and implementing, you know, asset performance tools, including machine learning models. And our focus today is going to be on the Maximo visual inspections, as they mentioned. So we'll talk a little bit about the machine learning process. You will see that on the demo in the application, but I want to give you a background on this. So the machine learning process, so this is a neural network, deep learning engine, right, to understand the images. So just so you can grasp how the machine learning process works, it works as it mimics the neural process that a person have. So when you teach a child to distinguish between red, green, and blue, right, you show them and they learn by that information that you associate with the image. Right? This is the same process here, right? So the first that we need to do, of course, is collect the image library, right? With, you know, a representative data, right? A representative set of data that can represent the different states of what you want the machine to learn. And then you need to teach what those images they mean, right? So there's two ways to do this in this tool. One is classifying the image, telling, for instance, this is a picture of a lion, this is a picture of a dog, this is a picture of an elephant, right? The second one is tagging. You tag an area of your image and you tell the machine learning model to focus on that. And we working with this business case, we tried both of those machine learning processes. So the tool is not a typical data science tool as those that are familiar with the machine learning modeling, that you have a data set and you separate the learning data set, the testing data set. This tool does everything for us. It's pretty automated. It's very, you know, directed to the user interaction. So IBM did a good job automating this. That happens behind. It's important to know how it works because then you can see the results and review the results, right? So you go through the learning process. We will see that IBM has made available many different engines like YOLO, GoogleNet, and others, right, that are available in the marketplace. So we can pick and choose and test different capabilities, right? And then you evaluate the performance of your model, right? And maybe you need to do different interactions to reach a point where you have a good level of precision and accuracy, right? So you may have to run different models with different sets of data and different combinations to reach what you want the machine to learn, right? You evaluate, and then when you're happy with the results of the machine learning model, you deploy the model. What does it mean, deploying the model? It's making it available for API calls. So you will see that the machine model, after it's deployed, it creates an API endpoint that can be used in applications that have that capability, okay? So going down a little bit, so this is the tagging and classifying process. As I mentioned, you can classify the images and you can go beyond. The tool allows you to select the exact area where you want the model to focus, right? So that information is crucial because that's what the machine learning model will learn, is exactly what you give them as primary information of what that image means, right? So once you have all the images tagged and classified, you can select. There are 3 training types, major training types. Each of these training types have different tools that can be used. You have image classification, and you have this picture of the lion, what I mentioned, right? Make the system understand that's a lion that is different from a dog, that is different from a cat, and so on and so forth. Object detection is more based on the geometric shape of the object. So in this picture, for instance, you can train the model to detect what is a microwave oven, what is a refrigerator, or what is a bench, right? So some of the models that use that kind of object detection, they also can distinguish color spectrums. And that's interesting in our case of the infrared spectrum. Action detection. We haven't gone that far, but that is supposed to identify a certain motion, right? So I've heard police departments around the world, some are developing models like this to detect infractions, right? Without having anyone to look, using cameras spread all around. In our world of asset management, I envision, for instance, that you can use the action detection for misalignment detection using strobe lights, right? With the same frequency that you have the rotation of the rotating equipment, and then you will have a signature of misalignment for a certain equipment. So that is a possibility there. So you do the machine learning model, and then the system will give you metrics and KPIs and graphics of how well the system is performing. So in this case here, we have a 97.92 level of accuracy, right? And you can see in the confusion matrix that the system learned exactly what we wanted to teach it. Of course, there is this 3% delta here, and you will have images that will fall into that one, right? Even because the model, when you train, you have a set of data that is limited in size, right? So you have to understand these are KPIs that are based on the size of your universe that you gave the machine learning model. So, of course, more accuracy, more levels of classification or learning, more granularity in the results will demand a larger quantity of images, right? And more granularity also in the learning data set, right? Which impacts the time of processing, the time of that machine learning model runs, and so on and so forth. So there is a balance that we need to reach using these models. So, and then deployment. As I mentioned, the system creates an API endpoint, so we can connect that functionality pretty much to any kind of system or application that supports API calls, right? Going on? Not yet. So, and what we will do is go over, a demo that we will kind of point out these different steps: image tagging, classification, the learning process, performance evaluation, machine learning model deployment, and making the machine learning model available, right? For this demo, what we did, we created an inspection form in Maximo Manage that is connected. One of the steps of the inspection form is connected to the machine learning model, and so it will give you the results of the thermography while you're doing the inspection on the field, okay? So work order created, inspection is mediated, the infrared image is captured, the infrared image is analyzed by the model using the model that is available and directed to, and you have the response. You select, and this is important, the way this tool works, the model gives you their suggestion of result, right? You can override that if you want. Let's say if the level of confidence is lower, you can override what the machine is telling me. The idea is that the machine is not ultimately responsible for the result. It just gives you support making your decision. All right? Having said that, let's jump to the fun part. And jump out of the presentation, yeah. So we need to do this. And then, okay, many of you are familiar with this. This is the Maximo Application Suite initial dashboard. And you can see here, there are many different applications, and one of them, visual inspections. So this is a little bit of a summary of what we saw: create data set, prepare data, train model, deploy model. Let's see the steps, how they work. So here are the data sets. So you can create different data sets of infrared images. You know, in our case, we had infrared images from different types of equipment, and we created this model mixing these different types of equipment. So the interpretation of the machine learning model is based on the delta temperature that is shown by the infrared spectrum. Okay, so we can open one of these models here and see the different types of equipment that were used. And where you see here, warning, right? This is the classification information that we provided to the machine learning model. That's our instruction to them. So they look at this and they see a warning. One of the challenges that we had, and it was mentioned by them, Average only keeps the positives, right? They don't keep the negatives. So you need to have the negatives to teach the machine learning model what is a negative, right? Or you will have a lot of false negatives, if you will, right? So then what we did, we used the library that they had available, we mixed with other libraries that we have available to create a distribution and the right granularity of warnings and normals that allows the system to learn, right? In different data sets, we had also used the tagging capability, not in this one. Let me just select one that we did that. This infrared training data set, we went beyond the classification and we built the frame where the machine learning model should look at, teaching the machine learning model what that means. It's a fault. Or, other images like this is a normal case. So tagging this, we give additional information to the machine learning model. So if you think about, in this case, we had warnings, okays, and inside each picture, we selected an area for the machine learning model to look at, right? Once you are, you have this data set compiled and classified and tagged, if you're going to use that, then you go and train the model. And that's what it shows in the slide, right? So there are three major groups of machine learning model. The first is image classification. The option that the tool gives us, in this case, it's GoogleNet, which is from Google. There are for object detection, there are more models that are available, right, from different sources. So each one of these models will have advantages and disadvantages depending on what you're doing. In our case, for instance, the inspection is not so much interested in gaps or geometric dimensions. It's more interested in the different colors of the infrared spectrum. So there are models here that work better for that when compared to others. In our case, we were more successful using YOLO. So YOLO is a tool that is available there. There is even a simplified one. And it's worth to try the simplified one to see if it reaches your objectives. So you don't need to boil the ocean. Try to be conservative. Try not to make a data set of thousands of images. Work things from the bottom to the top. So make your foundation first, and the first exercises will allow you to have a better understanding of what's going on in your data set to add new images if necessary, or even take out some other images, all right? So you run this. Depending on the tool that you're using here, it can take hours. It can take 6 hours to run in some cases of these things. Some others, not that much of the time, right? Mainly the image classification is pretty fast when compared to the others, right? Anyway, you train the model and the results come back, and we have here different models and results. So if we open one of these, for instance, this one, we can see advanced metrics. You have a whole information of the precision and accuracy of the model. This is not a good, I would say, a good result in a nutshell. It has a very different results in terms of faulty and normal. There are other models that were better suited for this. Let me select one of the, well, let me see here. So the average had a much better result, but don't be, this 100% here, although it looks very good, it may hide some disadvantages, and and this can be seen in this graph here, where you have the warning curve very different from the OK curve, right? So, in a nutshell, you run these models, you repeat, and you try to reach the best accuracy level. And once you're happy with it, you deploy the model. So in here we have 3 different models that were deployed. And we can take a look at one of these. And as I mentioned, right, the model has here an endpoint, an API endpoint. So pretty much you can copy this and take anywhere to other application that is able to make this call and make it work. So here, when you deploy the model, you can also test the model using pictures that you may have available. So you can look at these samples here of different images. And let's see, for instance, you have this image. It will load to the machine, and you will have the results back as soon as the Wi-Fi network allows us, right? But anyway, we are using an iPhone to connect to Wi-Fi, so it's not that bad. So see, here you go. You have this image as a warning, and it's 0.999 level of confidence, okay? We can test other images if you would like to. You know, this transformer, for instance, right? So this will be the result that will be reported in the inspection form once you use it. Right? So let's see here. 1. There we go. So 0.99, you know, for warning, level of confidence. So this is the power of using AI for these things, right? Because think about that. Thermography, infrared thermography, has been around, as we saw, for a long time, right? But when you use in this, when you ally, you know, good methodologies with artificial intelligence, you get great benefits out of this, right? You can scale up your thermography program and cover a lot more equipment and cover and mitigates a lot more risks that you may have with your fleet of equipment, in your distribution, in your transmission, in your power plants, and so on and so forth, right? So, of course, these are electrical equipment that averages a power company. This methodology can be used in other industries. Infrared is also used for detection of leaks, steam leaks, and things of that nature. So it can be used for that kind of things. So one thing that we're very happy is that the system was very comfortable and reached a good level of accuracy working with the spectrum, the infrared spectrum, right? So that was something that as soon as we selected the right images, we started to get higher and higher levels of accuracy and precision. So just let's move forward just to show, okay, that's all beautiful and everything. We will show an example on how we can take advantage of this functionality, right? So we will go to Maximo Manage, and I have assigned some work orders for me to do an inspection, right, on electrical equipment, and we will go there to see how that works. Bear with me. So I'm a technician. I go to my operational dashboard, and I probably have a lot of pending work to do. So I need to catch up. But anyway, so there are different work orders here with equipment inspection, and I have associated the inspection form. I'm not sure if everybody's familiar with that concept. We associate the inspection form, which is like a form, an inspection with steps and everything, we associate to the work order. And then when we do the inspection, it goes through those steps in the inspection form. So let's try one of these here. I want to do this one. And let's start the inspection, right? And this is showing, you know, the screen of a mobile device pretty much. It mimics that, right? Testing VMI. So you can have as many questions you have. You can, you know, have a detailed inspection, if you will, right? But this one we just created with 3 just to make it easy for us. So let's start. We start the inspection, and then we select what is the overall equipment condition. And let's say this is a clean equipment, everything is in place. And let's upload a file to the inspection form. So having said that, let's select this image. And with this step, we have uploaded the image to the inspection form. Once we have that image available, we can analyze the image, and that's what we do here. And that's when I send the API call to the machine learning model to be analyzed and to return the results. So let's click on that. It will go as fast as our Wi-Fi. But it doesn't take too much time as well. It's pretty straightforward. From here, you could even continue the inspection and go back. So we have the results. The results are in. So you go here to these 3 dots and you view the results. So it's faulty and 95% confidence, right? And it's showing where the machine learning model focused to come with this diagnostic. Okay? So you can select that, or you can go to normal. It's 95% confidence. I don't like that. Well, you know, go figure. But anyway, you have the option to change that diagnostic. Okay, so this information is stored in the inspection form, but you can connect this inspection form to the meters of the asset, right? And guess what? You can use the meters to calculate your health indicators, right? So this is something that we want to also indicate that, you know, when you have an application like this, we can go back and take advantage of this whole process in our advantage, right? So if we go to health, right? We can spot here the ones that require full attention. There's 3, you know, bad actors, as I used to call them. You have all the indications. And guess what? The Transformer Health Index, one of the components is exactly the thermography, right? And this configuration of the health indicators, it's out of the box of the IBM notebooks, right? This is highly configurable. You don't need to have all of those items to calculate the health of a transformer. But in this case, we have the thermography. And so the results can come from the inspection form. You load the image, you send to the machine learning model. That machine learning model sends back the diagnostics. You agree or disagree with that. That information is stored in the meter of the asset and automatically is available for the health calculation. everything in the same platform, right? So from my perspective, working with reliability engineering, that's the beauty of this, right? That you can take action very early in capture incipient failures and have time to prevent them from happening, right? One use case that we've been thinking and exploring, right? Of course, we still haven't done nothing yet, but as an idea, think about that. You have a fixed infrared camera in a substation or in your turbine room in a power plant, right? So that infrared camera is taking pictures with a certain frequency of the equipment, right? And it can send automatically that image to the machine learning model and have a diagnostics. So guess what? You transform thermography infrared into a sensor, right? Instead of needing someone to go and taking the picture and interpreting, having the interpretation of the data and everything, you have now a sensor, and that's a big, big advantage if you want to mitigate risks. Okay? So questions?
Q&A, we got 2 minutes. Anybody?
Yeah. Questions, comments?
Right here. Here, let me hand you a microphone.
Thank you. So when the model comes back with the result, 95% confidence, and you choose to disagree with that, does that go back into the model to train it? Like you've recognized that as, no, I don't agree. Does it train or change the model in any way?
No, that's not an automatic feature. You will have to review the model and run it again to update it. And one thing also that can be done if you have more images with levels of classification, instead of warning or okay, you could have warning red, yellow, and green levels of warning, like what we do with thermography, typically, right? If you have that granularity in the input data or the data set, you can train the model for that, right? In our use case, what we are trying to do is just to indicate if there is a warning, and that will raise that asset for your attention, and that will allow you to do or expedite other types of analysis, or even a more complete thermography.
How long did it take you to train the model, and how many images did you have to input to get to that level of confidence?
Well, in this, I would say it took, weeks to do it. I would say 3 to 4 weeks. It was also a learning experience for me. I was not familiar with the tool, but I found it very interesting, the approach of how it is, which is different from the predictive tools with more core machine learning models using Python, Jupyter notebooks, and that. This is a completely separate analysis, and in our case, it worked very well. Questions?
Yeah.